Hey everyone, and welcome back. This is the last class in our quadrilaterals unit. After this, we're going to go into similarity and trigonometry, followed by circles and 3D shapes. So we are over halfway probably through our content, which is great because we're at pretty much the halfway point in our course as well. So right on schedule. So last couple of classes, we've covered classifying quadrilaterals, looking at all their properties, solving questions based on using properties of quadrilaterals. We then moved into quadrilaterals on the coordinate plane and trying to prove that there are certain ones by showing that different properties exist. And then we went into inscribed quadrilaterals and trapezoid mid-segment theorem in our last class. Today is all about area and perimeter. And you may be like, oh, I did that like years ago. I've been doing area and perimeter for, probably 4 or 5 years now in math class. It's going to be a lot of recap and it's going to be a lot of applying that old knowledge with the new stuff that you now know. So you should find this a pretty easy day. Make sure you're dusting off the cobwebs, you're familiar with the terms, you know how to solve for area and perimeter of some of our more basic shapes, and then we'll carry on from there. All right, so we got perimeter on the coordinate plane, and then we're going to have 2D figures on a coordinate plane, and we're going to solve for the area and perimeter of both of those. What does it mean to find the perimeter of a shape? So what does that mean? And then what are 2 strategies for finding the area of a compound shape? So I'm going to give you 2 different ways of doing it today. Those are our essential questions. All right, so quick recap. Area is the amount of 2-dimensional space that a figure takes up. So you find area using like 2 measurements, typically like length and width. So there are 2 dimensions that go into finding area. It's typically a larger number. So the amount of area space takes up is going to be larger than either of the 2 sides, and usually measured in units squared. Perimeter, distance around the outside edges of a closed figure. So you're basically taking all of the edges, all the sides of the shape, and adding them together, and that is your perimeter. So area, you're talking about the space inside of the shape, so the enclosed area. And then perimeter, we're talking about adding up all the different sides of the shape to get the total length around the outside, as if you were going to put a fence around it. All right, for perimeter, it's going to be on the coordinate plane, so let's just recap on the formulas you're going to need. Distance formula, we've got d equals square root of x2 minus x1 squared plus y2 minus y1 squared. And then you could also use Pythagoras' theorem. So a squared plus b squared equals c squared, or if you're getting c on its own, it would be square root of a squared plus b squared. Straight into it. You guys should be able to do this based on everything we've done so far, but let's just kind of let's take a shot at it and make sure. So pause the video at this point and try and solve for the perimeter of the figure ABCD. Okay, so to solve for this, we need to find the lengths of the 4 different sides. So we've got the length of AB plus the length of BC plus the length of CD, and then finally the length of AD. So we got 4 different pieces we need to figure out. I personally prefer the Pythagoras' theorem method. So I will be looking at AB and I'd be saying, all right, well, if I create a right angle triangle out of this, so here's my right angle, then the hypotenuse is going to be the length of AB. I can count boxes to figure out my side lengths. So we got 1, 2, 3, 4, 5. And then 3 going down. So in my rough work, that's going to be 5 squared plus 3 squared is equal to, my missing side squared. So that's 25 plus 9. So 34 is equal to c. So my answer is going to be square root of 34. I'm going to leave it in square root form for now because I'm going to have some solving to do later anyway. BC. I'll do the same method. We got 2 and 3. So 2 squared plus 3 squared is 4 plus 9, which is 13. So we're going to get square root of 13 for BC. CD, we'll do it the other, or yeah, we'll do Pythagoras' theorem again, just for the heck of it. So all the way over and up, we got a height of 2. And I'm going from -3 to 5, so that is 8 units. So 2 squared plus 8 squared. 4 plus 64, so we're going to have root 68. And then finally, we have CD. So I'm going to do this one with distance formula. So 80. A is at -2,4. And D is at -3, -4. So this is going to be my x1 and my y1, and my x2 and my y2. And I'm going to plug all those in. So D is going to be square root of -3 minus -2 squared plus -4 minus 4 all to be squared. So -3 minus -2, so that's going to become a +2, which is -1 squared. And -4 minus another 4 is -8, all to be squared. So that's going to be 1 and 64. We're going to be adding those together. So we're going to get the square root of 65 is that final side length. So then perimeter, we're going to add all those together. So perimeter is going to be root 34 plus root 13 plus root 68 plus root 65. And this is when now you pull out your calculator, let those square roots go in, and we can round that final answer. So we're not rounding earlier than we need to. So root 34 plus root 13. Make sure you're closing each square root in your calculator, so you're not doing square root of all of these numbers added together and then doing too many square roots. All right, so when I add all those together, I get 25.749 or 7449. If I'm rounding, if you're not given anything to round to, 2 to 3 decimal places is usually a pretty safe number. I will usually tell you what to round to. So let's go 2 decimal places. So 0.74, this 4 does not round up the previous one, so it's going to stay as 0.74. So 25.74, and then that's just single units, so there's no need to put any other units on it. All right, so switching over to area. Key thing here is this postulate. Remember, postulate is something that we accept to be true. We don't have to go and prove it. It's our foundation for building other proofs. So the area of any shape, if you break it up into other figures, so fun fact, you can break any shape up into a series of triangles, that the area of all the individual pieces is the same as the combined area of the shape. So again, like angle addition postulate, segment addition postulate, you don't lose or gain anything by dividing a shape up into smaller pieces. All right, some useful formulas. Now, some of these you probably know already, some of them might be new to you. So if we think of a square, we should know that a square is a side length or the width squared. So all of these sides are W, they're all the same. Rectangle, length times width, we should know that one. Triangle, half base times height. So if you haven't seen that in a while, make sure you know your triangle formula. Parallelogram, we have base, and this is perpendicular height. So that's kind of an important one to note. It's not the slanted height of the parallelogram. The idea here is that if I were to draw a perpendicular line down and then another one from the corner, basically this triangle would slide in there and it would create a rectangle with base times height. My kite, I'm going to erase these so you can see it all again. Okay, so for kite, interesting one, it is the diagonals multiplied and then times a half. Now, reason for that is you've got two triangles, so it's like half base times height for the top, half base times height for the bottom, and since they have the same base, it simplifies out to just be half of the two heights multiplied, or sorry, the diagonals multiplied. Trapezoid, you have a half A plus B times H, and A is one side and B is the side that's parallel to it. So the two parallel sides, you're going to add them together, divide by 2. Now in your head, you should be like, that sounds familiar. So that part, the a half A plus B, that was the formula for the length of the midsegment. So do you remember that one? So basically, a trapezoid is the length of the midsegment times the height. So essentially, you are able to cut off these little triangles in the end, and then they would fill in on the bottom and create a rectangle for you. So it would be the midsegment times the height of the shape, and then times 2. All right, a rhombus. We're treating this one like it is a kite. Remember, a rhombus is a lot of the prior shapes. You could do, like a parallelogram, you could do base times perpendicular height because it is a parallelogram. You can do, trying to treat it like a trapezoid, you're basically going to get the top and the bottom. Average of those is still the same number times the height, so same thing again. Or in this case, we're treating it like a kite where you're multiplying the two diagonals and then dividing by 2. Okay, so now we're going to look at this idea of composite shapes or compound area. If you think back to English, a compound word is just 2 words that are individually words on their own that are together to make a new word. So like baseball, like you have a base and you have a ball combined, baseball. Compound area, same thing. We're thinking of it as different shapes that have been pushed together to create one overall shape. So when you think of it in that mindset, the shape on the left, we can think of that, if we draw you can see it in the second figure, but if we draw the little drop down here, now we've got a rectangle and a triangle. So this shape was made up of the 2 of those added together. So in your head or on paper, you're going to actually make these cuts, and then you're going to find the area of the figures that result from that. So in our case, you had a rectangle plus a triangle. We can find the area of both of those shapes pretty easily. So we go ahead and do that. Another way you could have looked at this was, if I drew this line in here, we would have had a trapezoid and a rectangle, or you could have kept that original line in there and you would have had a triangle, rectangle, and another rectangle. Like there's a lot of different ways you can approach this. Key thing for now is if you are making a triangle, it needs to be a right angle triangle because we are doing half base times height. There is another formula for triangles that are not right angle, but it's in our trigonometry unit, and I don't really want to venture into that just yet. So keep an eye out for that. Triangles need to be right angle triangles. All right, so this is the second method, and this is where you do composite area by subtraction. So in the last method, we would have looked at this one and said, all right, we've got, if I draw a vertical down in here, we've got a trapezoid and a rectangle, or we've got 2 rectangles and a triangle, and we could go solve that way. There is another way to do it though. So, if you're thinking of it in your head, you want to try and figure it out, pause the video and see, can you figure out another way to do this? The hint is kind of in the word though, subtraction. What we're going to do is we're going to say, well, if I kind of completed this shape, it would have been a full rectangle, and basically what happened was we chopped off a corner of it. We took away a triangle, and it would have been a right angle triangle as well. That's kind of key. So we had the original rectangle, which was a 10 by 12 rectangle, lobbed off a corner. So if we figure out the area of that corner, that triangle, we could subtract it and get the resulting area that we're looking for. So, looking at our shape up here, if this was 8 and the total length was 12, that means the missing piece must be 4. Total height was 10. We have 7 accounted for, it means 3 was missing, so that's where those numbers are coming from. And then we do our 2 areas. So 10 by 12 is 120, and 3 by 4, so it's 4 times 3 divided by 2 is 6. So if we do 120 minus 6, we get our 114 centimeters squared. So key thing, there are units on this one. So our area is going to have the units squared. All right, you're up. Try and figure out the area of the shaded part. I'll let you pause the video here and then I'm going to help you out. Okay, so in this one, we've got, this is probably best suited for solving by subtraction. We've got a large rectangle around the outside, and then we're cutting off two of these triangles. And nice thing to note, based on the markings given, these triangles are in fact congruent to each other because we've got right angles in the corner and side angle side, so they are congruent triangles. Really, we should have given more information such as right angles, but let's go with it. This is actually a rectangle. So what we'll do is we'll say, all right, what is 32 times 16? That's our rectangle. Minus, now we've got two of these triangles, so a half times 4 times 6. Now really the half and the 2 cancel and we get 4 times 6 because if you push the two of those together you would get a rectangle. But we'll carry on with this. So 32 times 16 is 512. And then minus 4 by 6 is 24. So you should have gotten 488. Unit is feet squared. So another good one of this one would have been to solve for the perimeter. So you would have been like, all right, I got to figure out, how long is this piece? How long is this piece? How long is this one? How long is this one? And then you'd have to use Pythagoras' theorem to figure out your two hypotenuses as well. Would have been a good question. I would go for it if you want something to practice on. All right, this is what questions are going to look like for you. Find the area and perimeter of the composite figure rounded to the nearest tenth. So looking at this one, we got a couple of options. I mean, you can get as complicated as you want. So you could say, all right, I'm going to divide this up into, here's a right angle triangle. We've got another right angle triangle. We've got another right angle triangle. We've got, say a rectangle, another rectangle, and we've got a trapezoid. So that'll be 1, 2, 3, 4, 5, 6 pieces that we would have to add up and solve. Could be done. Certainly, if that's the way you see it, if that's how the puzzle unfolds for you, that's the one you go for. On the other hand, I would look at this and be like, all right, if I put a box around this, what would that look like? So if I square off that corner, square off this corner, and this one, and this one. So now I've got a rectangle around the outside, and I would need to subtract out those pieces that are cut off. That's probably the method I would go for. So to do that, first off, we need the rectangle. So that is minus 4 to 4, so it's 8 wide, and 1, 2, 3, 4, and 7 high. So the area of the rectangle or the box that it fits in is 56 units squared. So that's our kind of starting point. Now we're going to start subtracting. So I'm going to label each of these. This is triangle 1, 2, 3, and 4. Helps me kind of keep track of which ones I've done, which ones I still need to do. So for triangle 1, it is 4 high, 4 wide. So we'd say the area of that is 4 times 4 divided by 2. 4 times 4 is 16, divided by 2 is 8. Triangle 2, it is 3 wide and 3 high. So 3 by 3 divided by 2. 9 divided by 2 is 4.5. Triangle 3, we've got 2 wide and 4 high. So 2 times 4 divided by 2 is 4. And triangle 4 is 1 wide and 3 high. So 1 times 3 over 2 is 1.5. So it's going to be 56 minus all of my green numbers. So we're going to subtract all of these. So 56 minus 8 is 48. minus another 4 is 44, and 4.5 plus 1.5 is 6, so that would be 38 total. Or a way to think about it, that would be 12.5 plus 5.5. Add those two together, you would get 18. So 56 minus 18, 38. And this is units squared. That's our area. Perimeter. Now you got to actually go around the outside of the shape. So we've got 4 different Pythagoras' theorem we need to do, and we also need to count boxes. So I'm going to erase the area stuff to give myself a workspace. I'm going to leave it up here just in case you need it. So when you're doing these kinds of questions for yourself, you definitely want like a nice bit of room to work, just because there's a lot of like rough work. Like it's not super hard math, but there is just a couple of calculations you need to do. And if you're doing it all in a calculator, it's great. But if you make a mistake, like you tap in the wrong number, you know it happens, and you don't show any of your work, I got nothing. I can't give you points for nothing. So I can't try and figure out what mistake you made, which number you tapped in wrong. So please be careful with that. All right, so we got VP. 3 squared, so we're still treating it as right angle triangles. I'm going to solve for the hypotenuse. 3 squared plus 3 squared, and then we're going to have to do the square root of that. So that's going to be 3 squared is 9, plus 9 is 18, so it's going to be root 18. PQ, nice easy one, that's just 1 unit. QR, we've got, oh, sugar. Okay, so made a mistake. Obviously, you can probably tell what it is. VP is not 3 by 3, so I'm going to borrow that. And I'm going to call this QR. And then I'm going to pick back up with VP, which was actually a 4 by 4. Hopefully you were yelling at the screen at home and you're like, oh, that was a mistake. Caught it, guys. All right, so square root of 16 plus 16 would be root 32. So we've got root 18, 1, root 32. And that is a terrible one, so I'm going to redo that one quick, just so there's no confusion at home. All right, and now we're on to RS. So RS over 2 up 4. So square root of 2 squared plus 4 squared. 2 squared is 4, 4 squared is 16, so there's going to be another root, not 18, root 20. And finally, oh no, not finally, we've got TS. And we can just count boxes for that one, that's 5 units. And now finally, VT. So VT is over 1 and up 3. 1 squared is 1, 3 squared is 9, so it's going to be root 10. So we got a root 20, a 5, and a root 10 all to be added together. So root 18, 1, root 32, root 20, 5, and root 10 all to be added together. Again, I didn't round because I want to be able to round my final answer to get the most accurate number. So we got square root of 18 plus 1 plus the square root of 32 plus square root of 20 plus square root of, plus 5 plus the square root of 10. So I got 23.5339. 23.5339. 9. Now we were asked to round to the nearest tenth, so this is going to be approximately equal to 23.5, and that's just units. All right, so that is one of our practice questions. Here's another one for you. Take a shot on your own. See, can you figure it out? Okay, so if we are going to solve this one, let's try and do this one by addition and see how it goes. So I'm going to draw in a line here. I'm going to do this one as well. Keep that shape simple. And then I'm going to cut off the bottom. So we got 2 triangles. I'm going to talk about why we can do this one in a second. Like, you could divide it into 2 right angle triangles, but really we could keep it as one whole one as well. So I'm going to come back to that. And then in the middle here, that leaves us with a trapezoid, but let's just it's easier to stick with rectangles and triangles for the most part. All right, so I've got 1, 2, 3, 4, 5, 6 pieces to this one. You want to make sure you get the area of all 6. So piece 1, that's an easy one. That's 2 boxes. Piece 2, we've got 1, 2, 3, 4, 5, 6 for the base. 2 for the height, all over 2 is going to be 6. Piece 3, we've got 1, 2, 3, 4, 5, 6, 7 wide by 3 high. That's 21. Piece 4 is a triangle that's 3 wide and 1 high. So 3 by 1 divided by 2, 1.5. Now this is the triangle piece 5 that I was talking about. We can actually leave that as a triangle because we are able to see the base and the perpendicular height. So if the base is on either a vertical or a horizontal line, it's still good to go because you can find the vertical height. You don't need it to be a right angle triangle. So this one is a base of 1, 2, 3, 4, 5. Height of 1 divided by 2, 2.5 units. And then triangle 6 or piece 6 is another 1 by 3 and divided by 2, so 1.5. All right, so that's all 6 pieces. We add those together. So 2 plus 6 is 8, plus 21 is 29. I'm going to put a little placeholder on that. So that's those 3 together. And then 1.5 plus 2.5 is 4, plus another 1.5 is 5.5. 29 plus 5.5 would be 34.5. So area, 34.5 units squared. All right, let's move on to perimeter. I'm going to erase all the rough work. So in this one, you're going to have to go around the outside of the shape again. Any of those slanted lines are going to need Pythagoras' theorem or distance formula to figure out their length. So it's a repetitive process, but it's not a super difficult one. And I'm just going to get rid of this as well. Okay, so let's start with AB. We've got 2 high and 1, 2, 3, 4, 5, 6 wide. So 2 squared plus 6 squared, square root all that. 4 plus 36 is 40, so this is going to be root 40. BC we can count, that's 1 box. CD we can also count, that's 6 boxes. DE, we've got over 3 up 1, so that's going to be a square root of 3 squared plus 1 squared. 3 squared 9, 1 squared 1, so root 10. EF is the exact same measurement, so that's kind of nice. We get to just reuse that root 10. GF We got up 1 over 2, so 1 squared plus 2 squared. 1 squared 1, 2 squared 4, so this is root 5. And AG is 1 and 3, so also root 10. All right, so we got root 10, root 5, root 10, root 10, 6, 1, root 40. Add all those together. Let's see what our perimeter is. All right, so with our calculators, root 40 plus 1 plus 6 plus square root of 10. Now, if you want to get fancy, you could do 3 times the square root of 10, so you got 3 of those, but not as fancy as some of you guys. So root 10 again, plus square root of 5, plus square root of 10. So I got 25.04, which rounded to the nearest tenth is just 25.0. Okay, so we're up to your turn. I've posted a PDF in Schoology. It's from our textbook, but when I went on the online textbook, it still looked like our old textbook, which was a disposable one. So there was a lot of space for writing in notes. So the page numbers don't line up with the current textbook. You can try and look on your MyHRW. You should be able to find this. It's the last section of the quadrilaterals unit. So you're in the second module and then the last lesson. Or I just have the PDF for you here as well. So what I want you to do, there's I think 20, maybe 28 problems. I want you to do any 10. And the idea here is like, if you want, you can do the easiest 10. Fine, that's your choice. But really what I'd like you to try and do is do a variety. Challenge yourself. So look for different types, so maybe some subtraction ones, some addition ones, different types of shapes, and then look for different difficulty levels. So if one's sticking out to you is like, that one looks a little hard. That's one you should really try and do. That's how you're going to prepare yourself the best. And then the actual thing I want you to submit is I want you to show me the work and solution to one of the problems. So write down the question number. If there's a diagram, maybe draw that, and then go through the process of solving it. You can choose to do this any way you want. If you're doing a picture, you're showing a picture of the completed process. Video, you're recording yourself as you do it, or if you're typing out a document, I would maybe do it in something like a slides or PowerPoint if you have access to it, because that way you can use the math type equation editor and so on. You can also just like try and record it on like a Zoom or something like that, get the whiteboard out and write digitally if you have touchscreen. If you are writing it out and then take a picture of it, you need to also make sure that your reasoning for each step is included. So almost treat it like a proof, like I did this step because. So I solved for AB using Pythagoras' theorem. I solved for BC by counting boxes. I found the area by doing length times width and then divided by 2 if it was a triangle, something like that. So one question you have to explain. And ideally try and pick some of the harder ones so that way like at the end we can just look and see what everybody did and you've got your full explanation. So this is going to be in a discussion. So posting links, posting pictures, posting videos, and then so by the end of the discussion we're like, okay, yeah, like there's all the problems done. You shouldn't like be copying anyone else, but certainly comment on them if you're like, oh, I see what you did there, or maybe you made a mistake, or if there's one you can't solve, post that one. Be like, all right, I started this one, here's what I've done, I'm stuck, help me out. All right, so we have a unit test on Friday. So make sure you have blocked out Friday, at least 1 hour of your day to devote to doing this unit test. I have a practice unit test posted in Schoology, so you can kind of pick up on that, take a look at what the questions are going to look like. Remember, it can look different, and it's going to look different because it's going to be a digital version of it in some way. So use that more for content and style of question versus like, oh, it's going to look identical to this. You only get one shot at it, so please make sure that you are giving yourself enough time to do it. You're not refreshing your screen or anything like that. And it's going to be a time test, so you don't have all day to do it once you start it. Reason for the timing is, you can try and use notes, but we're going to put a time limit on it so that you can't really use notes for every question because you'd run out of time. So it should be something that you're testing yourself on as well. So this is one way that I'm using to make it a little bit more legitimate. Topics to cover. We got the properties of quadrilaterals, so be able to list the properties, be able to put markings on a diagram to show those properties. Solving using the properties of a quadrilateral, you know that from our quiz. Proving properties from the coordinate plane. This is kind of the new topic since our quiz. The inscribed quadrilateral theorem and being able to solve problems about it. That was from the last lesson. Same with trapezoid midsegment theorem. And then finally, today's content, the area and perimeter on the coordinate plane. Okay, so our essential questions. What does it mean to find the perimeter of a shape? It means to find the length of all of the outside edges of a closed figure and add them together. And then strategies are finding the area of a compound shape. We can do it by addition. So you break the shape up into shapes that you can find the area of and then add them together. Or we can do it by subtraction, drawing a box around the shape and then subtracting out the pieces that you don't need. So for tonight, you've got our PDF worksheet. So that's from the pages of our textbook. And then you've also got practice for the unit test, and that gets us to the end of the week. You have that extra credit project hanging out as well. Feel free to get started on that. Make sure you check in with me before you pick a skill and start working on it. So let's just make sure that skill is something that you can work on and suitable for the project. All right, guys, I will talk to you soon.